Hi there, hope you have a fantastic day today. This lesson I will teach you trapezoidal rule. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. We can find an approximate area under the curve by finding the area of the trapezium. So let me just connect this first. So the area of the trapezium is a half of the perpendicular height. So this is the height, okay? It's the width of the strip, if you like. So this is h. And then this is to find the length of this, because x is b. So we can find the y value, will give us the length. To find the y value, the function is fx. We can just simply substitute b into fx. So in other words, the length of this is f of b. And the length of this is when a is equal to x or x equal a. So we can find the length of this by simply substitute a into the functions, that is f of a. So let me just redraw the trapezium out so you can see. So it's like this. So this is the height, and this line are parallels if you like. So this is f of b, and this is f of a. That's the length, and we want to find the area of this. And this is right angle. So to find the area of this trapezium, so we know that area is equal to a half of h and f of a, the two parallel lines add together, so f of b. And to find the perpendicular height, so we find the length of this, that's the h. So we simply just use b minus a, that will give us the length, that is the height. So that is equal to a half of h, that is b minus a, bracket, so f of a plus f of b. This can also be written as b minus a over 2 f of a plus f of b. So there you go. So this is the area of this trapezium. If we find the area under the curve from a to b, f of x dx approximately, that is equal to a half of h, or h over 2 f of a plus f of b. Or we can write, because it's h is b minus a, so I can write like this, b minus a over 2 f of a plus f of b. So there you go. This is trapezoidal rule. So let's just go through a couple examples. First one, by using the trapezoidal rule, find an approximations to ln of x from 2 to 5. First of all, for one subintervals, let me just do a quick sketch first. So ln of x is like this. Okay, so it's just a rough sketch. And then from 2 to 5. So this is 2 and this is 5. And we need to find the area, approximate area. So this is it. So to find this area, so we know that a is approximately h over 2 f of a plus f of b. Or you can write h is b minus a if you like. And we know the height of this is from 2 to 5. That's a perpendicular height. And to work this out, we just go 5 minus 2, or b minus a if you like. So 5 minus 2 is 3. So the height is 3, the width of the strip, okay? So that will give me 3 over 2. Now f of a, so this is f of a, the length of this. F of a is 2. So f of 2, so that give me ln of 2, because f of x is ln. So I can just simply substitute that in. So that is ln of 2. We add to find the length of this. So that is when x is 5. So when x is 5, y will be ln of 5, because the function is ln x. So ln x when x is 5, that means ln 5. So that is the y values. Okay, remember that. And then let me just write this down. That is ln of 5. So there you go. Now what I do, I just put that on a calculator. Otherwise, I can just simplify this first. So that is equal to 1.5 ln. So by using log law, so ln5 plus ln2 or ln2 plus ln5 is equal to 2 times 5, which is 10, ln10 if you like. Otherwise, just put down a calculator. So let me just quickly put down a calculator. So 1.5 ln of 10. Or you can type ln of 5 plus ln of 10 if you like. So that is 3 just make it 2 decimal places will do. 3.45. 3.45. So there you go. So therefore, okay, the area is, let me just write this down. So the area from 2 to 5, the function ln x dx is approximately 3.45 square units. So there you go. Part B. So for 2 subintervals, this means that we have 2 strips or 2 trapeziums, if you like. So let me just quickly draw the diagram out first. So just a quick sketch. So this is ln of x. And we start, this is 1 of course, and we start from 2 all the way to 5. And that is only 1 trapezium. So we need to have 2. So 2 strips. So that means we just cut this in the middle. And to work out the number in the middle, so what we do, we just go 5 minus 2 and we divide to 2, because 2 strips, if you like, divide by 2. So that should give me 1.5, because 5 minus 2 is 3, divided by 2 is 1.5. So therefore, the height for this trapezium is 1.5. So now 1.5 plus 2 is 3.5. So there you go. So what we do, we just need to find this area 1, and then we need to find the area 2, and we add them up. That will give us the approximations of the area under the curve. So A1 is equal to h over 2 f of A plus f of B. So there you go. And the height is 1.5. So let me just write this down. 1.5 over 2, and f of A is 2 here. So the rule is ln of A is 2. So ln 2. And we add ln of f of B. So B is 3.5. So ln 3.5. So ln 3.5. So this will give us this area here. And now I just put that on a calculator. So just go ln, okay, 2 times 3.5, give me 7. So ln 7. Otherwise, you can just put ln 2 plus ln 3.5. Still correct, okay? I'm just using log law, that's all. Then what I do, I times by 1.5 and then divide by 2. So there you go. 1.459 and so on. Let me just store this in memory A because I'm going to use this later. I press answer, shift, store A. So 1.46 for now. So that is equal to 1.46. Now I'm just going to go for area 2. So area 2 will give me, so area 2 is this area here. And we know that the height is 1.5. So the rule is this. I'm just using this rule here, of course. 1.5 over 2 f of A. In this case here, A is 3.5. So ln 3.5 because fx is ln of x. ln of 3.5. And we add f of B. B is 5 here. So therefore, ln of 5. So ln of 5. Close bracket. So now what I do, I just put that on a calculator. So I just go 1.5 over 2 brackets ln of 3.5 and we add ln of 5. Close bracket, close again. So there you go. 2.146 and so on. So it should give me 2.14, okay, equal 2.14. So what I do, I just add these two areas together. So the integrations from 2 to 5, ln of x dx is approximately equal to 1.46. We add 2.14. So that is equal to, so just go answer plus alpha A. So there you go. So correct to 2 decimal place, that is 3.61 square units. Okay. There you go. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me go through it with you. Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first of all, let me just do a quick sketch first, okay? So you can see exactly what happened. So first of all, we know that 3 over x, it is a hyperbolic functions. It's like this. But then because we have plus 1, so that means the graph moved 1 to the left. That's all. So let me just quickly sketch it. And this is vertical asymptote. So -1 here, your graph is just like this. And we need to find the area between 1 and 3. So there you go. We need to find the approximate area under this curve from 1 to 3. So therefore, the rule is we can just find the area approximate by using trapezoidal rule. So the trapezoidal rule is integrate from 1 to 3. 3 over x plus 1 is approximately h over 2 or b minus a if you like to find the length of the h. So f of a plus f of b. So height is the width of the strip. So this is from 1 to 3. We can just go 3 minus 1 will give me 2. So h is 2. So we just write 2 over 2. F of a, so the length of this, okay? A is start from a to b. So the smallest value is a, so which is 1. So f of 1, so f of 1 will give me x is replaced with 1. So this is the x value. So 3 over x plus 1 is the functions f of x. So that becomes 3 over x is 1. So 1 plus 1 is 2. So f of a is 1.5 if you like, because 3 over 2 is 1.5. And then we need to add f of b. So that is the length of this. So x is 3. So f of 3, because b is 3. So that becomes 3 over 3 plus 1, because x is 3, like that. So that gives me 3 over 4. So I just write this 3 over 4. Okay, so 3 over 4. I can just write 0.75. That will do. So now what I do, I just put that on my calculator. It will give me the area under the curve. But that's just an approximations, okay? 2 over 2 is 1. So I just go 1.5. We add 0.75. So there you go. 2.25 square units. There you go. So part B. So 2 sub-interval, okay, for part B. So let me just quickly sketch the graph first. This time, I just draw the top half, okay. So the graph is, I just draw like this. So that is 1, and this is 3. And we need 2 sub-intervals, that is 2 strips. So to work out the x value, so therefore, we just go 3 minus 1 because we want to find the width of the strip. So from 1 to 3 is 2 units if you like. So then we divide by 2 because 2 strip. So that gives me 1. So that means the width of the strip is 1. So therefore we go 1 plus 1 is 2. So halfway is 2. So let's just name this area 1 first. We just need to find this area. And then we find the second area. And we add them up. Okay. So A1 is equal to a half of h, or h over 2, f of a plus f of b. This is trapezoidal rule, okay? Keep that in mind. The height is the width of the strip, or you can just go a minus b over 2, okay? Just remember that. So the width of the strip is 1, so 1 over 2, and then f of a, because f of a is 1. So we know that the functions f of x is equal to 3 x plus 1. Don't forget. So a is 1. So f of 1. So 1 plus 1 is 2. So that is 3 over 2. 3 over 2 is 1.5. We add f of b. In this case, b here is 2. So 2 plus 1 is 3. So therefore, the function is 3 over 3, which is 1. There you go. And that will give me, so I just put that on a calculator. So I just go 0.5, because a half is 0.5, bracket 1 plus 1.5 is 2.5, if you like. So there you go, close bracket. So 1.25, so 1.25. So that is the first area. So then the second area, so this one here, let me name this A2. This is A2. Now to work this out, so just do the same process. So A2 will give me, so the width of this still 1, have to be the same height, okay? The width of the strip is 1 over 2, and just simply apply the trapezoidal rule. So a half of f of a, in this case, a is 2, okay? This one here, so 2, so therefore 2 plus 1 is 2, so 3 over 2. I just substitute 2 into the functions. So 3 over 3. So that is 1. Okay, let me just clear this. So it's 1. We add, so in this case here, b is 3. So f of 3. So 1 plus 3 is 4. So 3 over 4. So 3 over 4. Or you can write 0.75. So now what I do is I just put on a calculator. So I just go 0.5 brackets 1.75. So there you go, 0.875. So now what we do, we just add them up. That will give us the approximate area under the curve from 1 to 3. So there you go. Let me just write this down. So go therefore, the area from 2 to 3 with the functions x plus 1 dx is equal to, is approximately 1.25. We add 0.875. That will give me, so just put on a calculator. I just go 1.25. We add the answer because the last one we did was 0.875. So there you go. So just round up to 2 decimal place. So approximately 2.13. Okay, because it's 5, it's from halfway onward. We add 1 to 2. So the answer is 2.13 square units. So there you go. I hope you got all of them correct, and thank you so much for watching. Bye.